Hello, are there any questions?
I have a question. For our quiz next week, is it going to be on chapters 1 and 2?
Uh, For questions about the quiz, you can check the syllabus because it'll cover what we are covering. And let me look right here. I know chapter 1 is on there, but I don't think chapter 2 is on the first quiz. It's only the start of chapter 2, which will be on quiz 1, as well as it'll cover lab 0, lab 1, and lab 2 will be on quiz 1. Is
Okay,
that
thank
clear?
you. Yeah,
Okay.
thank you.
So what we finished today on chapter 2 will be the last of what you'd need to know for the quiz next
Okay.
week. Where am I? Let's get rid of that. I'll show that briefly. I'm still running the meeting conversion from the lecture. It's taking longer. They must have uploaded the system. Where's my window? There it is. So let me share the screen here. So there you can see for quiz 1, it's on chapter 1 and 10. We started chapter 2, lab 0, lab 1, and lab 2. And that has to be done by 11:59 p.m. Wednesday night. Today, what we're going to talk about in the lab is the microscope basics. It's down here.
Oh, I didn't realize the practice quizzes were gonna be like graded as extra credit. Is it too late to go back and do those?
Yes, it had to be done Wednesday at 11:59 p.m. The practice quizzes were extra credit. So you saw that it was worth 0 points and so you decided not to do it?
No, it just wasn't in the grade book, so I didn't even see it at all.
It's not in the grade book. It should be. Well, wait a minute. It might not be in the grade book because I literally transfer it over to the grade book, but there is a column for the practice quizzes. But it should have been on your calendar of events to do. If it wasn't, let me know and I'll look into that. But it
It
should have
was
been
not on the
your,
calendar.
it's not on the calendar?
No, it was not on the calendar. It was just in the modules, but it was not on the calendar.
Is there anything else like that, like something that's not on the grade book or the calendar that I should know about?
There should not be, but obviously I'll take a look at that, why that's not on the calendar. Like I said, with the grades there, I usually go through and give you the point for it. And then put it in manually in the grade book. So it might not be in the grade book that you can see, although you should see the column for where I put the practice quiz grade. But there won't be a reminder of that for that. But like I said, the practice quiz should be on the calendar. So I'll take a look at that. And anyways, you should have read chapter 3 on compound light microscopy. We'll now talk about lab 3, the microscope basics. And let me write a note to look in on why that wasn't on the calendar, because it should be. All right, I think we can finish that. Oh, it looks like the video completed for the lecture. All right, let's go to lab 3. Move that down here. All right, lab 3, microscope basics. You need to read the lab module and the class textbook on chapter 3 through the end of the section on the compound light microscope. There will be video clips, online exercises for this lab, and links found in the laboratory exercises section. So your learning objectives, you're not physically going to be using a microscope. However, upon completion of the lab module, students should be able to locate and name the parts of a compound microscope, along with describing their functions, calculate the total magnification for each objective that's used on a microscope, know the guidelines for focusing specimens with the different objectives. You should all start with the scanning lens, that's the 4X lens, then move up to the low power lens. Once you have it in focus, that's the 10X lens, and then move up to the high focus lens, that's the 40X objective, and then move on up to the oil immersion lens, and that's the 100X objective. Note that the low power objective lens is not the lowest, that's the scanning lens. And then the high power objective lens is not the highest, that's the oil immersion lens. I typically don't use these terms when discussing the lenses, although sometimes I use the scanning and sometimes I'll use the oil immersion lens. I usually use the power that it is, meaning I'll say the 4X lens, the 10X lens, the 40X lens, and then the 100X objective lens. Any questions about any of that? You should be able to estimate the size of a specimen when you see it under the different magnification powers or lenses of a light microscope. And what we do is we will give you a picture so that you're seeing the field of view, and then tell you what lens it is, or something similar to that. So even though you're not going to be using the microscope, you do need to estimate the size of a specimen when you're looking at it under a microscope. And you're going to do this virtually. Does that make sense? Hopefully. You need to understand the rules for proper microscope care and be able to define the terms associated with the microscope. You're not going to be physically working with a microscope, but we do have an in-class exercise where you will be working with a virtual microscope, meaning you will be working with a microscope over the internet. Any question about any of that? All right. So you need to memorize the names and the functions of these parts of the microscope. 1, the ocular lens or the eyepiece. 2, the objective lens. And that's the 4X lens we're looking at. 3, the stage. 4, the stage clip. That's for holding the microscope slide on the stage. I don't see 5, there it is. The moving the stage. I don't know, the stage adjuster or something like that. 6, the iris diaphragm. That is a shutter that opens and closes how much of a cone of light is coming up from the lamp, which is 12 right here. And for optimal viewing, you want to have a cone of light coming up. Can you guys see my hands? Probably not. There, I can actually see it a little bit. Can't get it in focus. My hands aren't showing up for some reason. Well, that's a bummer. Oh, there we go. So you want a cone of light coming up that's about the size of the field of vision of the objective lens. And when you have a big field of vision, my hand sort of disappears there, you want a large cone of light. So you open up the iris diaphragm, it's number 6. And then when you go to a higher power, you need to shut down the iris diaphragm so that your cone of light is approximately the size of your field of view under the objective lens. Any question about that? So remember, when you're using the lower objective lenses, you open up the iris diaphragm so you have a larger field of view. And that's with 6. And then when you go to a higher objective lens, especially the highest, you need to shut down that cone of light. And 7 is the condenser, which is together. It's not shown very well, but they're held together on the microscope. 8 is the coarse adjustment knob for focusing, and 9, the fine focusing. 10, the switch for turning the microscope on and off. What do they call them? I don't remember. We'll just say the switch for turning it on and off. And then 11 is the rheostat for turning the lamp higher or lower. 10 turns it on and off, but 11 adjusts the amount of light that comes through. Any question about that? And then the lamp 12 right there. And there's the key right here. Hopefully I got all of them correct. So 10 is just called the light switch, but I just call it the switch. And I call number 11 the rheostat because that's what it is, but you can also call it the light intensity dial. And 11 is called the light bulb or the lamp or the illuminator. Number 6 is sometimes called the diaphragm, but it's also called the iris diaphragm. And I mentioned 1 ocular lens, also called the eyepieces. There's a question in the lab, so I'll mention this. The objective lenses, there are 4 of them, at least in our microscopes that we have in the lab, and you'll never go into the microscope lab, but the objective lenses are on a rotating nose piece, and that's how you can move this whole thing is the nose piece that rotates around so that the different objective lenses can be used. You need to know this table. You're going to be using it to perform the lab, but it gives the name of the lenses, which I don't tend to use, and then the power of the objective lens, the total magnification, and this is set up for the microscopes in our lab. The total magnification is the power of the objective lens times the magnification of the ocular lens. And as you can see, all of the ocular lenses in our lab are 10x. So 4x times 10x will be 40x. You can have an ocular lens which magnifies 20x. We don't have any of those. They're more expensive and they're just harder to work with. Any question about them? You do need to be able to figure out the total magnification, and you can use this table or you can calculate it. And all you do is multiply the objective lens times the ocular lens. You should know the depth of field of the ocular lenses. There, I can actually see this. The 4x objective lens has the deepest depth of field. So for this object, you can see the top of the object and the bottom of the object because the object's in 3D. And as you go up in power, the depth of field will reduce to what you can see until you get the oil immersion lens, where, see if I can do this right, where all you're going to see is a plane of the object, simply seeing one, how would you call that, plane of the object. So the depth of field for the oil immersion is very narrow. The field of view for the 4X lens is the largest. My hands sort of disappear there, you can kind of see them. 4X lens has the largest field of view. And then as you go up in power, the field of view decreases until you're seeing the field of view, which is only a pinprick. It's very small, the oil immersion lens of the 100X objective. Some comments, the 4X lens is the easiest one to use because you have the largest field of view and the largest depth of focus. And so it would be easiest to find the object with the 4X lens. And then the 100X lens is the hardest one to use because it has the smallest field of view and the smallest depth of field. Any question about that? When you're viewing an image, you should know that they are more than just magnified under the microscope. They're also inverted and reversed. So when you look at the letter E right here, it will have an orientation under the microscope like this, larger and magnified, but inverted and reversed. Another note is when you're using the 100X oil immersion lens, it only works, that's not exactly true, it only works well, I'll word it that way, when you're using oil. And it can work in other circumstances, meaning without oil, but you're not getting any magnification over the 40X lens, and the 40X lens is easier to use. So if you're not using oil, it'd be better to use only the 40X lens. Oh, I need to keep the note up here, never mind. I already talked about that. The iris diaphragm, besides allowing how much light can get in and closed, it's more importantly used to show the contrast between the specimen and the background of the field of view. And usually the background of the field of view is just the glass slide. And to increase the contrast, you need to shut down the iris diaphragm so that the cone of light coming through is equal to your field of view for the objective lens. So we can say the iris diaphragm is the most important tool in adjusting the light, but realize you adjust it more to get contrast. Like if you need more light, you don't open up the iris diaphragm. What you do is you turn up the rheostat. Is that clear? All right. When you first use the microscope, you should use the 4X objective lens, also called the scanning objective lens. This is the one that's easiest to use. You will see the largest field of view and the greatest depth of field. And then focus on the object. So start with the 4X lens and then adjust the stage using the coarse focus to bring the object into focus. You should, when you're first using the microscope, open up the iris diaphragm so the cone of light is equal to the field of view. And so the cone of light will open up everything you can see under the microscope. So you have the iris diaphragm open or open as large as you do with the 4X lens. you have the iris diaphragm, the lamp up to what's easy to view, meaning you don't have it so bright it's hard to view, and so dim it's also hard to view. You then place the stage, slide on the stage, cover slip up, have the clips in place, and adjust it so that the object will be directly under the lamp. Use the coarse focus knob to slowly raise the stage until the object comes into focus. Move the object you're viewing under the center of the field of view. I'll talk more about that. And then switch to the fine focus and bring the object in fine focus. Any question about any of that? Now, why you move the object into the center of your field of view is because the next step you do is you then move up to the next higher magnification lens, next objective lens. And if you're viewing something way over here, and the center is right here, and then you go up in the next objective lens, you're only going to see this part of the field of view because it's got a smaller field of view, and the object that you were looking at is out of the field of view. So you need to move the object you're looking into the center of the field of view before you go up to the next higher objective lens. At this point, you never use the coarse focus knob again. That the microscopes are set up to be in parafocal vision. And all you need to use is the fine focus to focus the specimen when you switch from one objective lens to another. If you do use the coarse focus, you've now blown what you had already focused in. So it's best to start all over, use the 4X lens, and then use the coarse focus to bring it into focus, and then use the fine focus. So once you have it into focus, fine focus, you should only use the fine focus knob to adjust it. And then you repeat steps 9. Again, for each objective lens you go to, move the object under the center of the field of view. Switch the magnification to the next higher objective lens, and then fine focus in on it. And you do that all the way up until the oil immersion lens, if you're using the oil immersion lens. Now realize, before you use the oil immersion lens, you must add oil. And there is a procedure for adding oil. And what you do there is you turn the ocular lens so it's not directly on the specimen. I don't know if you can see that. There it is. You can see it there. You turn it so it's halfway off, halfway in. Bring something with a drop of oil on the slide. Put one simple drop of oil on the slide. And then you bring the oil immersion lens into the drop of oil, meaning the oil immersion lens is so close to the slide that when you bring it in over the specimen, it should be in the drop of oil. If ever you're using a cover slip, this is just a side note, not terribly important, you should make sure that the oil immersion lens does not, my fingers will be the cover slip, does not bump the cover slip or touch the cover slip. That can scratch the oil immersion lens as well as, move your specimen, move the cover slip. Oil is used because it has the same refractive index as glass and allows more light to be gathered by the lens, increasing the resolution and the clarity of the image. And we'll talk a little bit more about that. Whenever you use oil, the oil must be cleaned from the objective lens. And you clean the oil with lens paper. Lens paper is certain paper that has had the wood fibers of the paper removed from the paper. That's why we call it lens fiber and the lens paper. And that's why the lens paper does not scratch the lenses, as the wood fibers have been removed from the paper. Regular paper, like this paper or any other paper, including chem wipes, have wood fibers in them and they can scratch the lenses. The lenses are the most expensive part of the microscope, and scratching them damages them, so they won't focus as well, if at all. And you don't want to scratch the lenses. Any question about that? So you need to clean the oil off the lenses and only use lens paper. There are a couple of other things you can use. You can maybe read about that. You could use a swab. What is that? A cotton swab. You can also use a lens cleaner. But in this lab, we're not going to talk about them because you guys aren't really going to be using a microscope and cleaning it. So we'll just say students generally only use lens paper. And if in the lab you were to need additional cleaning, the student usually asks me to clean the lens with lens cleaner. And I go get the lens cleaner, put it on lens paper, and then clean the lens. Very rarely do we ever use a cotton swab to clean the lens. All right, so students are not going to be performing any activity with a real microscope. If you actually have a real microscope, you can do some of this. And it would be good for you, but not required even if you have a microscope. The table has already been filled in for you so that you can get started on this lab. You are expected to know the information contained in the table and how you use the formula in point 5 below. And even though you cannot perform the activity with a real microscope, we have a virtual microscope that you can use to do this activity or another activity. I think it's another activity. All right, so read through the procedure. Here's the table you're going to be using. So it has the name of the objective, the magnification of the objective, the diameter, which you're supposed to measure. We filled it in for you. The diameter both in millimeters and micrometers. And this is the field of view, how much area you can view under the objective lens, like the 4X objective lens. You need to know this size so that you can estimate the size of the specimen that you're observing. For example, if you see something under the 4X objective lens and it fills up half the field of view, then you know it is 2.25 millimeters large in size. Any question about that? All right, so you have a laboratory exercise that you can do, and we expect you to know and understand the material in this exercise. So read through the exercise. Activity 3, you don't need to do. It's just on using a wet mount. You can read through it if you want to. You're not going to be handling a real microscope, but you are expected to know how to correctly store a microscope, so you should read the storage and microscope. It should be put away cleanly in the correct way. Read through that. You will be tested on that, by the way. All right, you should know the terms of the microscope. And then the laboratory exercises. View the following clips, video clips on using a microscope. And then you putting oil and using the oil immersion lens on a microscope. And then practice your microscope skills using a virtual microscope. You need to click on this link and know that it is a little slow in downloading. So give it time to download. And when you do that, let me click on the link. This will probably take a while, because I've got some things going here. And then practice naming the parts of microscope. That will be giving a quiz, an online quiz. It's going to take a while to load, so let's go ahead and come back to where I was. Where the heck was I? Here we go. So click on this link and practice the parts of the microscope. Where is it? Here it is. It's still loading. All right, there's the microscope. It's a little tricky when you don't know how to use it. That's why I'm showing you. You click on these buttons here, and to start using the microscope, click on Explore. And then what you do is you click on the microscope to use it, but you need to put a slide in there first. So take the samples, click on the sample slide block, get a slide. We'll get a plant cell. I mean, that's a good one. And then it puts it over there. And now you need to start focusing. We'll use the 4X lens. You notice it's blurry. It's because we have to coarse focus. It looks a little over focused, so I'm going to come back someplace around here and then start fine focusing. That looks pretty good. And normally you'd move this to the center of the field of view. You can't do that in this, but normally you would. And then go up to the next objective lens and it rotates it. And there it is there. From here on, you should only use the fine focus. And I'm not seeing much improvement. So about there, let's go up to the 40X lens. Actually, that's pretty fine, actually. Say about right there for this cell. Okay, any questions? You can adjust the light. Actually, when we go to the 100X lens, add oil immersion lens. There's the oil. Oh, it added the oil for you. I thought you'd have to go over here, but didn't remember. Let's add a little more light here. Fine focus. Looks like about as good as we can get. That's the light. That's a little better. All right, any questions on how to do this? Remove the slide. Put it back there. And then lens paper tells you got to clean the lens. There's the lens paper. And there you're cleaning the lens. And that's putting the slide away. All right, any question on how to use the microscope, the virtual microscope? All right, so play around with it. Let's go ahead and open this link. Um, You start this is clicking this right there. Download here, it'll start downloading things to your computer, so you don't want to hit that link. So start with the arrow here. And then it says the parts of the microscope. Something, no. So we'll go one. Oh, here you go. You click on the link. So that would be one. Body two. I don't remember how you take this clear. Ocular lens. I'm supposed to switch something here that I'm not seeing. Click the tags below to find other quizzes on the same subject. Supposed to fill in an answer here. I might have to get back to you. Telling you the names. Well, let me try this and see if that does something I'm not remembering. I think it wants you to download something. Yep, I don't want to do that.
You're almost done. Click Open File in the top right to continue.
I have to look into this. I'm not seeing what working anymore. And maybe you have to download this to get it to fully work. But it has the different parts of the microscope. So for the ocular lens, you just click there and it'll give you the name of it. Actually, it's not working now. Oh, I got to press that, sorry. That's the ocular lens. And that's the two body, which you don't need to know. There's the rotating. Oh, it's starting to work now. Low power adapting. Ocular. No, it doesn't description. Oh, yes, it did. It did go to the medium power adapting. That's wrong. Oh, I see. There's the iris diaphragm, so you're supposed to go here. Now I see what it does. It takes time for it to run. The light source, and you click on where the light source is. Base. No, sorry, it was 14. Line adjustment knob. Oh, I think that's here for ours. That's not like our microscope. Power switch. You see that here? I don't see it. Oh, there it is. All right. So once it starts running, let's try starting that again. Press play. Actually, it's telling you what to do. The arm. And that would be here. So it's telling you what to do, and then you click on the link. The blue tab for which one. And the 13% correct. Okay. Any questions about that? That took me a long time to figure out. You guys probably would have been much quicker than I was. And then don't put in your answers in the lab module. Click on the worksheet to lab 3. Fill in the answers for the worksheet. If you do not get this to work, don't just give me 4A and the answer. You need to put in at least a little bit of the question. So you should start with, and then you say the 4X objective or the scanning objective. Okay, so you need to tell me a little bit what the question is. And then most of you are just filling your answer right here in this worksheet and then submit the worksheet. And then in question 2, You have to say that this is a field of view of the microscope when using the oil immersion objective. And a typical cell is 2 micrometers in diameter. You have to figure out how long the field of view is, and then how many cells can fit across if each of them is 2 micrometers long. How many can fit across the field of view? If the field of view is 2 micrometers, it would be 1 cell could fit across. And if it's 4 millimeters across, then 2 cells could fit across. So figure it out that way to get your answer. And this one will be worth twice as many points as the other questions. Any questions on the lab? If not, I will be here until 8 o'clock to answer questions. You can work together, but all answers must be your own. Okay. I noticed last time that a large number of people had the same mistakes. And so that's telling me you guys are working together, which I don't disapprove of. However, your words should be your own. Now for this one, you're all going to have either the 4X objective for this answer or the scanning objective for this answer. So I will allow the same answer, but occasionally when you're giving a sentence answer, you should not have the same exact wording. You should use your own words. Any question about any of that? Oh, and by the way, if you do get together, you should check the answers that somebody gave you because their answer could be wrong. All right, if there's no further questions, I'm going to stop recording and stop sharing. I'll be here to answer any